So this is our model of work of our group. This is a baseball and golf ball. Okay, the experiment was used as general full factorial 2k factor designs. Use 3 factor variables, 2 factor digitally adjustable variables, and 1 factor non-adjustable variable as follows. 1. Ball. Include golf and space jam balls, which are non-adjustable variable. 2. The pressure include 0.6 to 1.8 pressure, which are adjustable variable. 3. The angle is 30 to 45 and 45 degree, which are adjustable variable. Configure the replicate value is 4 from formula in multiply, and the design equal 4 multiplied 2 cube equal 32 runs. This is our hypothesis test we show in the slide. The experiment's data is divided into 3 pressure ranges as follows. 1. Pressure at 0.6 to 1.2 bar. 2. Pressure at 1.2 to 1.5 bar. Next, pressure at 1.5 to 1.8 bar. In order to obtain more accurate value in the experiment. Because if the pressure value is long distance, Minitab program only calculate the maximum and minimum values. This may cause the response optimization equation. Determining the target value at the intermediate pressure range may cause this value to be distorted. Therefore, set the pressure to 3 range.
In ANOVA, at pressure 0.6 to 1.2 full model, we will check the factor. In the two-way interaction, ball and anchor model have non-significant because p-value is more than alpha. Then we make reduced model. Reduced model make ball and anchor model into lack of it. Let's do analysis. First normality, we check p-value. If it's more than alpha that we have set, we conclude that it failed to reject hypothesis HO, so residuals are normally distributed. Equivariant, we also check p-value. If it's more than alpha, we can assume that failed to reject SO, so variants are not significantly different. Independent, we only check approx p-value for trade and oscillation of p-value more than alpha. We assume that OK. Fail to reject the hypothesis HO, so residuals have no trade effect and residuals have no cycle effect. The power and sample size. Power value is 0.8 and 0.85. If effect high value, it's easy to detect. The graph shows the slide. Graphical plot the 2k factor design. If factor is t, the graph is cube. Plot because 2 power t, the graph shows the slide. Power and sample size detect difference 1.49013 is recommended and actual difference equal 57.4374 is more than effect. So we conclude replicate equal 4 is enough. Distance, power, sample size detect difference.
Next, in the contour plot graph in the pressure 0.6 to 1.2. We will consume that if the interaction have the significant, the graph will be curved. If you look the plot, you can see line will be curved. It can be the interaction has a significant in direction high to low. Set the angle low and pressure high. In surface plot, show the high of hand pressure and angle. Interaction plot. Interaction plot is compare earn fraction and analyze what the graphing interaction affect 2K equation. And for graphic, you can see the graphic look very different. And you need in the ball and pressure plot, the word cut is much different. You can look at slope is high and difference and point is start. But in pressure and angle, it's not much difference. Next, regression equation. Regression equation is a distance formula. Code will be -1 and 1. And cost will be in the slide. Response optimize. Response optimize is we can put the target we want and calculate the pressure, angle, and ball. And then it's tolerable for our experiments. CBK well is the process capacity index. The experiment is the accuracy of the shot, which determines the distance is a 8 cm within the range of the shot 1. If you look at the shot 1, target CPK of 45.6875 divide toward LSL but don't not fall out of the specified range. The first it can be concluded that the processing capacity can be according to the specified route. But if target 68 is fall out of the first range,
In ANOVA at pressure 1.2 to 1.5 full model, we will check the factor. In the factor model, non-significant because p-value is more than alpha. We will reduce the model and it shown on the slide. Reduce model. We make pressure multiply angle and burn multiply pressure multiply angle model in the lack of it. Residual analysis. First, normality we check p-value. If it more than alpha that we have said, we could that it failed to reject hypothesis H0. So these still are normality distributed. Test for equivalence. We also check p-value if it's more than alpha. We can assume that fail to reject H0. So variance are not significantly different. Test for independence. We already check a block p-value for 10 and for acceleration. If p-value more than alpha, we assume it's okay. Fail to reject the hypothesis has 0. So this still have no 10 effect and this still have no second effect. Power value and simple sign. Says zero value is 0.8 and
0.85. If effect high value is easy to detect, the graph shown on the slide.
Power sample size detect different 1.15024 is recommended and actual difference equal 58.969 is more than effect, so we concluded replicate equal 4 is enough. Control plot graph. We will consume that if the interaction has not significant, graph will be not curved. Surface plot, as shown in the slide. Interaction plots compare each factor and analyze whether graphical interaction affects 2K equation, as can be seen from the figures in the mini-tab. The distance between parallel figures is very small, so there is need to reduce the model because have not significant. Equation distance formula coded will be -1 and 1 and formula uncoded will be in the slide. Response optimizer, we can able to put the target that we want and calculate pressure and angle and ball that's suitable for our experiment. The CPK value is the process capability index, but the experiment is the accuracy of the shot, which determines the distance sigma equal x centimeter within the upper-lower spec of chart 1. The target CPK target of 95.65 deviate towards RSL but does not fall out the specified range. Therefore, it can be concluded that the process capability can be according to the specified value.
In ANOVA at pressure 1.5 to 1.8. For model, we will check the factor in the factor model have significant because p-value is less than alpha. We will not reduce the model and it shown on the slide. Next, residual analysis. First, normality. We will check p-value if it is more than alpha. That we have said, we conclude that it failed to reject hypothesis H0. So residual are normally distributed. Next, test for equivalence. We also check p-value if it is more than alpha. We can assume that fail to reject H0, so variants are not significantly different. Next, test for independence. We only check apart p-value for trend and for oscillation. If p-value more than alpha, we assume that OK fail to reject hypothesis H0. So residual have no trend effect and residual have no cycle effect. Next, power value and sample size. Set power value at 0.8 and 0.85. If effect high value, it's easy to detect the graph shown on the slide. Next, graph critical plot. The 2K factor decide if factor is 3. The graph is Q plot because 2 power t. The graph shown on the slide.
Our sample size detect difference 0.914061. Is recommend an extra difference equal 70.75 is more than effect, so we conclude replicate equal 4 is enough.
Next, contour plot graph. We will confirm that if the interaction has significance, graph will be curved. Next, surface plot, as shown in the slide. Next, interaction plot. Compare each factor and analyze whether graphical interaction affects 2K equation. As can be seen from the figures in the mini-tab, the distance between parallel figures is very small, so there is no need to reduce the model because have significance. And next, ligation equation. Ligation equation distance formula code will be -1 and 1, and formula and code will be in the slide. Next, response optimizer. We can able to put the target that we want and calculate pressure, angle, and ball that's suitable for our experiment.
So, in conclusion, we use 2K model to do these experiments, but the equation is accurate max and min distance because 2K is linear equation. So, we decided to divide pressure into three ranges: is 0.6 to 1.2 bar, and 1.2 bar to 1.5 bars, and the last one is 1.5 bar to 1.8 bars. An angle between 30 to 45 degrees. We use non-adjustable space ball and graph, and then we do the experiments to find CPK 3 values, correct 30 times per 1 values for calculate the accuracy. So, for CPK target at 45.6875, pressure at 0.6 to 1.2. We can see that our curve is in ranges between upper lower specs, so we can conclude that our process have potential and performance. Next, for CPK target at 68, we can see that our curve is in range between upper lower spec too. We can conclude that our process have potential and performance. So CPK equals CPL value because the graph deviates to LSL. The last one, CPK target at 95.65, pressure at 1.2 to 1.5. We can see that our curve is in range between upper lower specs. So CPK equals CPU value because the graph deviates to USL. We can conclude that our process has potential and performance. Our problem in this experiment is whether pressure gauge visual reading is inaccurate, and the weight of the ball affects accuracy. The last one is the first shot doesn't count because the pressure is unstable. Thank you.